Hi, I'm Varshika. The project title for our group project is Retail Price Optimization. Coming to the introduction, this project is all about finding the best price for a product or service through optimization. We look at things like who our customers are, how much it costs to make what we are selling, and what's happening in the market. The main aim is to optimize the price, meaning what we want to find the perfect balance that makes the most money without making our customers unhappy. By analyzing historical data, businesses can gain valuable insights into the optimal price point that optimizes profits without compromising customer satisfaction. This process ensures the long term success of the business, fostering both financial sustainability and customer loyalty. Coming to the dataset overview, these are the significant variables in the dataset. There are 676 samples with 30 variables and there are no missing values. You can have a look at the variables with the description beside it. And this is the summary of the dataset. Coming to the EDA analysis, the first one is the distribution of total price. This visualization tells us about the distribution of total price. Here the x-axis of the histogram shows the price range while the y-axis shows the number of products or services that fall under each price range. Quantity versus total price. The visualization of quantity and total price is a scatter plot as shown here, and the scatter plot shows that there is a positive correlation between quantity and total price, which means as the quantity increases the total price also increases. Total price versus product category. Here we can observe different product categories such as gold, garden tools, health beauty products, perfumes, etc. So the total price is distributed relatively even across the different product categories. There is no single category that dominates in terms of total price, but we can observe that health and beauty category has the highest total price, followed by watches and gifts category. Total price versus weekday. Here, a box plot is used to represent the total price versus weekday visualization. The median total price is highest on weekdays, with Monday having the highest median price of all weekdays. The IQR is also widest on weekdays, suggesting that there is more variation in total price on weekdays when compared to weekends, and there are more outliers on weekdays than on weekends, which means there are some products or services that are significantly more expensive on weekdays when compared to weekends. Coming to the price versus weekend, here the median tool price is higher for products or services purchased on weekends. The interquartile range is also wider for products or services purchased on weekends, which means there is more variation in total price on weekends than on weekdays. There are more outliers for products purchased on weekends, which means that there are some products or services which are significantly more expensive on weekends than on weekdays.
Thank you, Ashika, for explaining the EDA part of the project. So this is Bharat Uppala. So I will be continuing what Vashika is explaining the with the data set. So like one more analysis, we what we can do is like comparison with the competitor products. Okay, so competitor analysis is quite essential. So therefore, like we what we did is like we compared the unit price and unit and the shipping of the every product of those three different competitors. So for this, we simply calculate the difference between each pair. Like suppose for competition one, what we can do is like difference between the unit price of the product minus so difference between the competitor one price. So that gives us the like difference between the unit price and the competition price. Similarly, we can competition 2 we can calculate the similar way like unit price minus competition 2 price, and similarly for the competition 3. So we, as you can see in the left side, the competitor 1 price versus price difference per unit, and so the gap is heavily between the health beauty products, as you can see. for the competition one prices with the normal price of the product. And when we see the competitor to price difference per unit, as you can see the bed bar table, when compared to competition to price, the unit price is higher, so that's why it is below the zero. So, and you can see that health beauty has the highest difference of the, price gap between the competition 2 and the unit price. Similarly, we can, on the right side, we can see the competitor 3 price difference per unit also. So coming to the correlation features with the unit price, as important as an important relationship between, like, it is important to know the correlation between the future, variables and the dependent, like, unit price. So correlation of different features with unit price. So the left side graph shows that the futures have the positive correlation with the unit price, such as the product name, length and total price, free price, and product rate and product photos. So this means that these features increase, the unit price is also likely to increase. For example, products with the longer names has higher total prices, higher feed prices and heavier weights, and more photos are more photos are likely to be like more price expensive. So the graph also shows that the following features have a negative correlations with the unit price, such as customers and product score. This means that when the futures increases, the price will automatically decrease. So this is what the negative correlation meant to be. So coming to our optimization, the main part of the project, optimization, execution, and the performance. So coming to our mathematical model, like, what is the basic model of our optimization problem. So initially, what we consider is the decision variables. So decision variables, we took we took product price, free price, and fixed price of each product, and the customers for each product. Basically, customers for each product means like monthly demand of the product. Okay. So, and the product price, we have considered, like, we have limited the product price between lower bound and upper bound. So lower bound is like it should be greater than zero, and the upper limit should be, it should be below the competition price, so that our product is competitive among the market. Similar to product price, we consider free price also. Like, lower bound is zero, and upper limit is below the competition price. And the objective function is to obviously to maximize the revenue. So what should we like expected return? So expected return is like the quick sum of product price and the free price, product price plus free price into monthly demand. So that gives us the maximum revenue. So this is our objective function to maximize the revenue of the of that data set. And constraints, coming to constraints, what constraints we took is like, all the prices of products should be less than like competition 1 price, competition 2 price, and competition 3 price, so that the customers will buy our product more. uh, and one more constant we took is like, monthly the product, the quantity of the product we produce, like, it should be, it should be meeting the monthly demand of the product. So this constraint meets the monthly demand of the particular product. So by using all these decision variables, objective function and the constraints, so this is a mathematical model. So we run this program in the in the Python using the Groby optimization tool. So we solve the mathematical model to find the optimum product price and free price and the customers for each of the product. So this is the output we got. So in the output you can see that, so optimal prices for each of the product, like bed 1, garden 5, and the console, etc, etc. And similarly in the bottom you can see optimal free prices. So like, for each of the product, and similarly you can see optimal customers in the bottom of the page. So this is the basic output of the model what we have explained before, the mathematical model. So this output of the model we run in the Python using the Gurobi package. Coming to conclusion, so this Gurobi model for retail optimization is successfully formulated and optimized. So basically, our decision variables, the product prices, fleet prices, and the customers for particular month, have been successfully calculated. So the objective function to maximize revenue is also formulated based on the decision variables. So the in like I said before, the model also incorporated a monthly demand constraint to ensure it meets monthly demand. Following the optimization process, the result were extracted and printed. So revealing the prices and fleet prices and the customers. So this is basically our optimization model, uh, which we used Gurobi package in the Python to execute this one. Thank you.